Now we need to know about some terms for going deeper in EIGRP. The first thing is AD. AD is administrative distance. For EIGRP, we use two administrative distance. The first one is 90 and the second one is 170. 90 for internal routes and the 170 is for external routes. For example, this is R1, this is R2, this is R3, this is R4. Here we apply different routing protocol, that is, for example, I am using OSPF here. This is our EIGRP network. These OSPFs route are sent via R1 in this EIGRP domain and via R3 in this EIGRP domain also. For example, this is a network that is redistributed by R3 in EIGRP domain. So this network's AD for EIGRP is 170 because this network is not belong to EIGRP or this domain of EIGRP. It belongs to different routing tables. So for this network, EIGRP consider 170 as a AD. But for this network, this is the internal network of EIGRP. This have AD as 90. Now EIGRP have a different AD also. This is not administrative distance. This is advertised distance. Advertised distance, or you can say reported distance. Reported distance. This is the metric of remote network as reported by neighbor. For example, this is R1, this is R2, this is R3. Here a network is. R2 have some metric to reach this network. R1 also have some metric to reach this network. R2 send a packet to tell R1 that this network is reachable by me. R2 says to R1, this network is reachable by me or by my this interface, and the reach to this network, my metric is this. This metric is called AD or administrative distance for R1. For example, this is R1, this is R2, this is R3, and here is the network. For reaching via R2 to this network, the metric is, for example, I am having a metric A. Via R1, this network is also reachable but R2 sends a packet to R1 and says network, this is network 1 for example. The network 1 is reachable by me and the metric for me to reach network 1 is A. This is a metric to reach this network via R2 by R2. So R2 can reach this network via A metric. So R1 consider this metric as advertised distance. For R1, advertised distance for this network is A, and R1 know what is the metric to reach R2. For example, the metric by R1 to reach R2 is Y. This metric is Y and this metric is A. That is know by the R1 as the advertised distance. So the advertised distance is A and the reaching R1 to R2 is Y. So to reach R1 to this network, the total distance is become Y, that is this, plus A, that is this. So this plus this become the total metric to reach this particular network. So R1 is used advertised distance here. This is the use of advertised distance. Simply you can say this is the A, or you can say advertised distance is the metric of remote network. This is the remote network as reported by our neighbor. And this is the best path to reach this network by R1. So this is called as a FD. FD is feasible distance. Feasible distance. For example, if R1 have multiple, this is R2, this is R3 and this is R4. This is R5. Here is the network. It also advertises some distance or a metric to reach this particular network. This is also advertised to R1, a metric to reach this network. So R1 have multiple path to reach this particular network. So R1 have multiple reported distance. And now R2 runs an algorithm that is dual diffusion algorithm. Diffusion update algorithm. R1 run this algorithm and calculate the best path. For example, this is the best path to reach this network. So the metric of this path is called as FD, feasible distance. So don't confuse with AD or advertised distance. AD means advertised distance. Don't confuse with advertised distance and feasible distance. Feasible distance is the total distance to reach a particular network, and the advertised distance is the distance or metric to reach a particular network that is reported by our neighbor. Here the next thing to know, that is successor. The best path to reach a particular network is called successor. For example, R1 have three paths. R1 choose the best path via dual algorithm. This best path is called as successor. and this successor is shown in routing table. These all paths are not showing in routing table. Only the successor show in the routing table. There is a condition where a second path is also shows in the routing table. For going to this topic, or we need to know about feasible successor, that is FS. Feasible successor. For example, you can say R1 is here, this is R2, this is R3, this is R4, this is R5, is connected to this router, and here the network is. So R1 have two paths to reach this particular network. R1 select this path as the best path, so this path is a successor. And what is the feasible successor? You can say a feasible successor is a path whose advertised distance is less than the feasible distance of the current successor and consider as backup of the successor. This is the backup of the successor, but all links that are available to reach this particular network are not considered as a feasible successor. For becoming a feasible successor, there is a condition. The condition is this link is not a successor and follow a condition. The condition is AD, that is advertised distance, is always less than to FD. If a link that is not successor and via this link we can reach the particular network and this link is not a successor and also follow this condition, then that link is considered as feasible successor. This condition is mostly needed to follow to becoming a feasible successor. And this feasible successor are saved in topology table. Actually, EIGRP uses three tables. What are these tables and what is the use of these tables we will discuss about later in this video. For now, you can learn like this. This feasible successor are saved in topology table. EIGRP will keep up to 32 feasible successor. In the topology table. Now, we discuss about the tables in EIGRP. There are total 3 tables. The first one is neighbor table. It contains information about the specific route. The first one is neighbor table. It contains information about the specific router with whom neighbors relationship have been formed. It also displays information about the hello transmit intervals and queue counts of uncounted hello acknowledgement. Each router keeps state information about adjacent neighbors. When a newly discovered neighbor is found, its address and interface are recorded and the information is held in the neighbor table that is stored in the RAM. Sequence number are also used to match acknowledgements with update packets. The last sequence number received from the neighbor is recorded to that, so out of order packets can be detected. The second table is topology table. It contains all destination advertised by neighbor routers, holding each destination address and a list of neighbors that have advertised the distance. Simply, you can say it stores the route advertisements received by each neighbors. All routes in the same AS or same autonomous system are stored in the topology table, including successor and feasible successor. All routes are saved in topology table. The, the third one is routing table. Routing table is also used in EIGRP, same like we are using in RIP or OSPF. It stores the routes that are currently in use to make local routing decision. Or you can say it contains the routes via which the packets will flow. Now let's check the difference between these tables. The first one is neighbor table. Neighbor table is like this is router 1. It sees like this router 1 that is connected via FA 0 by 0. Router 2 is connected via FA 0 by 1 and so on. This is a neighbor table. And now if we come with topology table, then the topology table is sees like this. The router 1 and the destination is like 10.0.0. This is the destination address. Then it is successor. For example, it is successor or feasible successor. Then it is connected via FA 0 by 0. Then the router 2 and the destination address is like 20.0.0.0. This is successor or feasible successor that is mentioned in this column and it is connected via FA 0 by 1. Now if we come with routing table, as you know routing table have information about successors only. So the router 1 and the exit interface is FA 0 by 0 and it is successor. So this is routing table. These are the difference between these three tables.